In this video, we are going to look at the reactions of aldehydes and ketones. This is the part one of the reactions. You can see some questions out here, like what is the action of hydrogen cyanide on ethanol, acetone, and another reagent is sodium bisulfide. And then there are certain examples on Grignard reagent. And then there are some reactions on the derivatives of ammonia, like hydroxylamine, hydrazine, phenyl hydrazine. If you can solve all these questions on your own, then we don't have to look at the video. But if you are not able to make out how these questions can be solved, then please go through the video completely and try to pause the video in between and solve with me so that you can solve all these questions independently. We should try to understand the nature of the main functional group in aldehyde and ketones before we see the reactions. This particular carbonyl group is unsaturated, that is, a double bond is present there. So one bond is sigma and one is pi bond. And we know that unsaturated system undergo addition reactions. But if you see the polarity of the bond, this carbon is electron deficient because oxygen is a withdrawer. So the addition reactions which aldehydes and ketones are giving are usually nucleophilic addition reactions where a negative ion, let us say like Cn minus, can attack on this carbon, and then when you make one, you break one. So basically what is happening is the addition reactions which are given by aldehydes and ketones are nucleophilic addition reactions. Other than addition reactions, aldehydes and ketones are also giving us condensation reactions that we will see in the last part of this discussion. So aldehydes and ketones will give us two kind of reactions: nucleophilic addition and condensation. We are looking at the first reaction of aldehydes and ketones. This is a nucleophilic addition, and the reagent which we are using is hydrogen cyanide. So this is addition of hydrogen cyanide on aldehydes and ketones. So we have taken one question like what is the action of HCN on ethanol. So first what we will do is we will write the structure of these two compounds which are given to us, that is ethanol and hydrogen cyanide is already there. So we will write ethanol plus HCN. Ethanol is a 2-carbon aldehyde as we know, and therefore what we are doing here is writing a 2-carbon aldehyde, CH3CHO. And we know the polarities, like carbon has delta plus and oxygen has delta minus. Hydrogen cyanide is known as a weak acid, and it is breaking down with equilibrium like H plus and Cn minus. So we have Cn minus in the system, that is a nucleophile, and this Cn minus will attack on this carbonyl carbon, and when you make one, you will break one. So oxygen will get the minus charge, and that minus charge will pick up the H plus ion. So basically what is happening is HCN is added across the double bond, just addition reaction is taking place. Cn is the nucleophile, so we can call this reaction as nucleophilic addition reaction. So what we will write is nothing but a product where oxygen has been transformed into OH because H is added and Cn is added on the carbon. So this is a very simple addition reaction where double bond is going into single bond and oxygen is getting H plus and carbon is getting Cn minus. The product which is formed has two functionalities. One is Cn, that is cyano group, and the other one is hydroxyl group, alcoholic group. These compounds which we are getting are named as cyanohydrines. So the compound which we have got here is obtained from acetaldehyde, so it will be called as acetaldehyde cyanohydrine. Okay, and if you want to describe this reaction is in a simple sentence, that what you will write, that when nucleophilic addition of HCN takes place across the double bond O, it gives us acetaldehyde cyanohydrine as the product. On the similar pattern, what we can do is we can try to solve this question. What is the action of HCN on acetone? So what you will do, you will write the structure of acetone and then you will react with HCN. So this is acetone, CH3, C double bond O, CH3 and hydrogen cyanide again. And we know the polarities are exactly similar in terms of distribution of charges. That carbon is delta plus and oxygen is delta minus, and Cn minus is supposed to attack on this carbonyl. So we will have Cn minus in the system, which will be generated from the dissociation of HCN, right? And Cn minus will attack, the bond will open up, and addition reaction will take place. So we will be again getting two functional groups here. One is OH and other one is Cn, and double bond has been transformed into a single bond because addition reaction has taken place. The compound can be named as acetone cyanohydrine, right? So this will be acetone cyanohydrine, and you can just write a simple uh, statement: when nucleophilic addition of HCN takes place across the double bond O, it gives acetone cyanohydrine as the product. We can try our hand at some of these examples, that what is the action of HCN on ethanol, try to solve it, then take propanol and solve it, take 2-methyl propanol, acetone, benzaldehyde, add few more aldehyde or ketone like butanone, right? And you can try to solve these equations for uh, various aldehydes and ketones, and the reagent will be HCN. Just remember that all these compounds have carbonyl group and carbon is electron deficient, and because of that in all these molecules the same logic will work. Cn minus will attack here. When you make one, you break one, and you will be getting corresponding cyanohydrins as the product. The second addition reaction is the addition of sodium bisulfite. The question which we are going to solve and then understand this equation question is uh, what is the action of sodium bisulfite on ethanol? What you will do is write the structure of ethanol, which is nothing but acetaldehyde, and NaHSO3 is sodium bisulfite. In sodium bisulfite, this hydrogen is acidic. It is like it can be given out as H plus ion, and the lone pair of sulfur is basically attacking. Uh, it has lone pair, so it can be given to this electron deficient carbon, and the bond will open up. So basically, when you are writing the product, you will make the bond between carbon and sulfur, and you will open up the bond. O will become O minus, and that O minus will take H plus ion from NaHSO3, so it will be becoming OH. I will write the product here, and you can note here that this is the acidic hydrogen, which is now on oxygen, and sulfur has attacked on this carbon with its lone pair, so we are connecting sulfur here, and we write the remaining part SO3Na. So these are again the addition products from aldehydes and ketones, and they are just bisulfide addition product. These compounds are solid in nature, and we can get them as crystals after the reaction. We will solve one more example. What is the action of sodium bisulfite on acetophenone? So we will write the structure of acetophenone first, and we will write NaHSO3. Acetophenone is CH3CO and a phenyl group, and what we know again is the bond polarity is such that carbon is electron deficient, oxygen is electron rich, and the lone pair of sulfur will attack on this carbon, and the bond will open up, and we can complete the equation. So this is how sodium bisulfite can get added across the double bond to give us addition product. Uh, what you can do is basically take some more aldehydes and ketones and work out all those reactions with the same logic. that sulfur lone pair is attacking on the electron deficient carbon. So I'm giving you some of the molecules which you can use for more practice. I'm adding butanone also here, right? And I will give some common name like isobutyraldehyde and acetophenone. I have already given to you. Okay, this much is enough for some more practice. This is another reaction which is nothing but nucleophilic addition reaction, and this reaction is with Grignard reagent. It is a very important reaction which can be used for the preparation of primary, secondary, and tertiary alcohols. When we are using formaldehyde and when we react Grignard reagent with formaldehydes, various type of Grignard reagents, then we will get different types of primary alcohols. When we are using aldehydes other than formaldehydes, then we'll be getting secondary alcohols. And when we are using ketones, then we'll be able to get tertiary alcohols from Grignard reagent and ketones. So this is how we can complete these preparations of primary, secondary, and tertiary alcohols. In order to give you a general idea of how the reaction proceeds, I am taking a very simple uh, Grignard reagent, which is CH3MgBr, and what I am doing is taking one aldehyde, and the simplest one is, you know, that it is formaldehyde, that is one carbon aldehyde, right? And what we will do is we will react them together. Please remember that in all the reactions of Grignard reagent, on the arrow you must write dry ether condition. So in ether the reaction will take place. As far as the polarity of the carbonyl bond is concerned, we know that this carbonyl bond, carbon has positive charge and oxygen has minus charge. In Grignard reagent, we know that magnesium is a metal, and being a donor, it will generate minus charge on the carbon which is connected to magnesium. So here what we see is two carbons with different polarities. This carbon is electron rich, and on the other hand this carbon is electron deficient, right? So what we will do is we can imagine an attack from this electron rich carbon, and it will go and make a bond with electron deficient carbon. And when you make one, you break one. So let us write what we are going to get next. CH3 has attacked on the carbon, that is this carbon, right? So CH3 has attacked on this carbon. So CH3 is attached to this carbon, and this carbon of aldehyde has how many hydrogens? Two hydrogens. I am writing them, right? And I opened up the bond of C double bond O. So now that double bond O is written as single bond O, and the remaining part of Grignard is written on oxygen, that is MgBr. This is the addition product which we will be always getting, right? And we will be putting them into the square bracket. And what will happen next is we will work up the reaction or stop the reaction with water and HCl. And what will happen is this OMgBr bond will be decomposed by water HCl, and what we will be getting is CH3, then CH2. I am writing this part together as CH2, and OMg will be replaced by H, right? MgBr will leave and it will form the corresponding bromo hydroxide, that is MgBr and OH. This is how the reaction gets completed. Please remember that now we will solve many examples, and in all those examples the first condition will be dry ether. Just remember the polarities. Minus charge will attack on the plus charge. In all the Grignard reagents, the carbon which is connected to magnesium has more electron density, it is electron rich. And in carbonyl, this carbon is always electron deficient, right? And because of that, what we can do is make the bond between carbon and carbon. That my rich carbon is attacking on electron deficient carbon, and that is how the reaction gets completed. Do remember that when we make one, we break one. So we write in the next step, the double bond O is written as single bond O, and then you give the remaining part of Grignard reagent as MgBr, right? Then you decompose it with HCl and water. So these reaction conditions will be always similar. The polarities will be same, only the Grignard will change, and we can change various aldehydes and ketones and get so many different products. Right now what we have before us is ethanol, right? And as per the classification, you can see that OH is connected to the primary carbon. So this is a primary alcohol. As I have told you in the previous slide, that formaldehyde is giving us primary alcohol when it is reacted with Grignard reagent. Okay, so this is how we can complete various examples. Okay, so what we will do is the question which I have just solved for you in the previous slide, I will take it again in a different way. Let us say we are asked that what is the action of methyl magnesium bromide on formaldehyde. So what we will do for such kind of questions, we write the structure of the reactants which are given to us and the product which is given to us, right? So in this case, basically both the reactants are given, methyl magnesium bromide and formaldehyde. So we'll write the structure. Methyl magnesium bromide is CH3 MgBr and formaldehyde is SCHO. Now the polarity, we know that this carbon is electron deficient, and in Grignard, the carbon which is connected to magnesium is electron rich in nature, and what you will do is you can make that carbon to attack on the other carbon, right? And when you make one, you break one. So we will write the product. On the arrow you will write dry ether and write the addition product. Here what you can note is the black part is corresponding to your formaldehyde molecule or methanol, right? And this addition product, if you notice that uh, double bond of oxygen has become a single bond, right? And across the double bond, CH3 is added on carbon and MgBr is added on oxygen. So this is the other way of looking at the reaction, that CH3 MgBr has been added in such a way that CH3 is added on carbon and MgBr is added on oxygen. So addition reaction is taking place across the double bond. So various ways are there to look at this reaction, and what we will do is work up the reaction and break it down with the help of water and HCl, right? And the product will be ethanol, and the side product is MgBr, and this is a primary alcohol which we are getting, right? So this is how you can try to solve some examples. I will give you another example now. In this example, the same thing has been asked differently, and the question is like, how will you convert methanol into ethanol? So methanol is the reactant, right? And ethanol is the product in this case. So what we will do, we will try to write the structures of these two compounds. Methanol, you know, H, C double bond OH, and ethanol also you are familiar with is CH3CH2 OH. Now what you can do is compare the reactant and the product. What you see here is carbon is connected to two hydrogens and one oxygen, like it is like CH2 and O, right? So this part is actually present here, CH2 and O. Okay, so this part is coming from aldehyde. So the remaining part should be coming from the Grignard reagent. So I will cut this unit, that is CH3. I will take it out, like CH3 I have taken out, and I will convert it into corresponding Grignard like CH3MgBr. So this is how you will be solving this question, right? So I am just removing it for the sake of more clarity, right? So what you do, you write the structure of the starting compound and the structure of the product. You see the match them, and what you will find that you will see the similar part. And once you are able to note the similarity, you will be able to find the differences also. So this is the different part which is coming into the molecule. And this part is converted into the corresponding Grignard reagent. So this is the Grignard reagent. And what we will do, we will note the polarities here. This is electron rich and this carbon is electron deficient. And when you make one, you break one. So complete the equation, make the addition product, right? And follow the arrows, just follow the arrows. CH3 will be going to this carbon. So CH3 is connected to the carbon, right? And bonds opens up, bond is opening up. So it is O minus will pick up MgBr. So it is O MgBr. And we know that working up is done with the water HCl system. So you'll be getting CH3, CH2, OH in place of OMgBr, and the side product is MgBrOH. So this is how you can solve this equation. Okay, we will see some more examples now and try to solve them. How will you convert formaldehyde into propane 1-ol? This is our next question. So basically what you will do again, try to write the structure of formaldehyde first and then write propane 1-ol. Propane has 3 carbons, so you make a 3 carbon chain, right? And on for first carbon you are putting OH, right? And then you balance the hydrogens like CH2 and CH2 and CH3. This is our product which we are supposed to prepare from formaldehyde. And what is formaldehyde? Is HC double bond O and H. Okay, so now we are supposed to write these two compounds to solve them. So we are writing the structure of propane 1-ol. This is numbering should be starting from this side, right? 1 to 3. So this is propane 1-ol and this is formaldehyde. What you do after that, you see the similarities, and the similar part is carbon with 2 hydrogens, right? Carbon with 2 hydrogen and 1 oxygen. So here you see that carbon with 2 hydrogen and 1 oxygen. This is also a carbon with 2 hydrogen, carbon number 2, right? But it does not contain the oxygen part. So this is not similar to our formaldehyde. The carbon which is containing 2 hydrogen and also connected to oxygen. This particular system is similar to our formaldehyde, right? So basically then we identify that this part is coming from formaldehyde, right? And now you know the complete reaction sequence, first dry ether and later on you are putting HCl and water. So this hydrogen will come after putting water and HCl, right? So what is remaining is the Grignard reagent. So this is coming from Grignard reagent, okay? So what we can do is now complete the reaction sequence, that I am taking it out and I will convert this part into Grignard reagent, okay? So this is the Grignard reagent, CH3, CH2, MgBr. And polarity wise, magnesium being donor will generate minus charge here. This carbon is electron deficient because of oxygen, right? And when you make one, you break one. So you will complete your equation and addition product is formed where these two units are connected together, right? And then you work it up by water and HCl and you will get propane 1-ol. So this is a very efficient way of writing and solving such equations, where how will you convert, how will you complete this kind of questions are asked. What you do, you will be given the names and convert these names into structures. So you must remember how to make structures from names. So the nomenclature part is very important in these type of questions. Unless you are able to make structures, you won't be able to solve the problem. Okay, a small description can be added when formaldehyde is reacted with Grignard reagent. Then the final product formed after hydrolysis is primary alcohol, which is propane 1-ol. Here we have another example. How will you convert formaldehyde into 2-methyl propane 1-ol? So you just work out by the same logic. You can pause the video and try to solve it on your own. What you will do, try to make the structure of formaldehyde and 2-methyl propane 1-ol and then try to solve it. I hope that you had already paused and you had tried to make the structures. I will solve it for you now. 2-methyl propane 1-ol. This in this name, the parent is propane. So how many carbons I need? I need 3 carbons to make chain of propane. I number it 1, 2, 3, and on the first carbon 1 all, right? I have OH on the first carbon, right? And on the second carbon I have 2 methyl, so second carbon has a methyl, 2 methyl. 2 is the position of that methyl, right? Now we balance the hydrogens like CH2 and CH and CH3. So this is the compound which you are supposed to prepare from formaldehyde. Formaldehyde structure now you are well known with is HCH and double bond O. And now you can see the similarity here, like CH2, carbon containing 2 hydrogen and connected to oxygen as well, CH2O. So basically this functionality is present, CH2O part, can be identified in this molecule like this. So these two are identical or similar type of uh, structures. So once you are able to find the similarities, you will be able to note the difference. The different part is like, cut it from here. CH3, CH3 is the different part. So I will take it out, CH3, CH and CH3, right? And I'm numbering it also, second and third. This was the part I have taken out. So I cut the bond between carbon number 1 and 2. So carbon number 2 has now one valency less. So I can add MgBr, and now my Grignard is ready. Now on this carbon number 2, we have delta minus charge. In our formaldehyde, we have delta plus charge, so we can complete the reaction. Okay, so this is how we are going to solve. I will clear this slide out, and then we will see the actual uh, complete solution here. So let us go for it. We have formaldehyde, we have this compound which is nothing but 2-methyl propane 1-all. You can see the numbering, right? 1, 2, 3, 2-methyl propane 1-all. And what you do, you are identifying the similarity, that is CH2O, that is CH2O part, right? And the remaining part is supposed to be made into Grignard. So this is the remaining part. CH3, CH, CH3, CH3, CH, CH3. MgBr is connected to the central carbon, middle carbon, right? And polarity wise, we know that this carbon is electron rich and this carbon is electron deficient. And when you make one, you break one. Dry ether conditions, complete the addition product. And after completion of the addition product, what you will do, you will decompose this to convert this OMG into OH by addition of water and HCl. So this can be a very straight and simple way of making primary alcohols. So in all these many examples so far which I have covered here, all the alcohols which we are getting are primary alcohols. As you see, you can see here also that this carbon is the primary carbon and OH is attached to the primary carbon. So this alcohol is also a primary alcohol, right? So as we have already seen in the summary that formaldehyde produces primary alcohol with various Grignard reagents. Okay, so this is all about the primary alcohol. Okay, this is the new question in which methyl magnesium bromide is supposed to be reacted with acetaldehyde. So far we were looking at the formaldehyde reactions. Now we have changed the aldehyde. It is acetaldehyde. You know the structure of acetaldehyde, CH3 C double bond OH, and it is supposed to be reacted with methyl magnesium bromide, CH3 MgBr. Again, the logic is remaining the same, like if you see the polarities, carbon is electron deficient in the aldehyde, and in the Grignard reagent, the carbon is electron rich. It has delta minus charge, right? Condition remains the same. Dry ether will be the condition, right? And as per the polarities, what will happen? Minus will go and attack on plus. When you make one, you break one. So you write the addition product here. You can see that this blue methyl is basically coming from Grignard reagent. The other methyl is already present in the aldehyde, right? Okay, and then we will decompose it with the help of water and HCl, and the product will be CH3 CH3OH. As you can see that OH is present on the secondary carbon, so basically this alcohol is a secondary alcohol, right? And the name for this alcohol will be propane to all, right? Like I can number it 1, 2, and 3. 1, 2, 3 is propane, 3 carbon chain. On the second carbon, I have OH group present, so propane 2-ol is the name for this alcohol. It is also known as isopropyl alcohol. That is the common name for this compound, isopropyl alcohol. Okay, so this is the short description of the reaction. Methyl magnesium bromide reacts with acetaldehyde to form secondary alcohol, which is known as isopropyl alcohol. Okay, now we will go to, we will solve another question. How will you convert acetaldehyde into butane 2-ol? What we need to do here is make the structures of acetaldehyde and butane 2-ol. Acetaldehyde, you know, it is CH3 CH double bond O. What about butane 2-ol? We need how many carbons? We need 4 carbons, right? Number it 1, 2, 3, 4. On the second carbon, I am putting OH, so that is butane 2-ol. I will balance the valencies by putting hydrogens, right? And now I will see the similarities and differences between these two structures. So what I need is a carbon which has a CH3 and it is also connected to O. So this is the carbon which is connected to CH3 and O. So basically this part is basically my aldehyde part. And once I am able to see the similarities, I will be able to note the difference also, and this is the different part. So what you will do, you will take it out and convert it into Grignard reagent like CH3, CH2, MgBr. So this is how we can get our starting compound. I will rub out these structures and we will solve the example. So what we are doing here is removing these structures, and now we will go for the solution. So this is acetaldehyde and this is the product which we are supposed to prepare, right? Butane 2-ol, 1, 2, 3, 4. You can see the aldehyde part which is reflected in black, and the remaining part is my Grignard reagent. So we will make a Grignard reagent, CH3, CH2, MgBr. Polarities are known to us by this time, delta minus here and delta plus here. And when you make one, you break one and complete the additional product and then add water, you will be getting the corresponding alcohol. This alcohol, as you are noting it, is a secondary alcohol which is present on a secondary carbon, right? So aldehydes other than formaldehydes are giving us secondary alcohols. Okay, we are now solving these Grignard reagent reactions with now ketones. So acetone is given to us, acetone. And the question is, what is the action of methyl magnesium bromide on acetone? Methyl magnesium bromide CH3MgBr is supposed to be reacted with acetone, that is CH3CO, CH3. Polarities are basically known to us. So what we will do is delta minus here and delta plus here, right? And minus will go on plus. When you make one, you break one. So you complete the addition product. Here what you can note is these two methyls are basically belonging to ketone, and this is the new methyl which is introduced into the molecule with the help of Grignard reagent, right? And at the end, when you are working up the reaction, basically OMG becomes OH. Now you note that OH is present on this carbon which is tertiary carbon, right? So what we can say, ketones are giving us tertiary alcohols when they are reacted with Grignard reagent. As far as the name of this compound is concerned, it is known as tertiary butyl alcohol, right? And it can also be named as, I can number it 1, 2, and 3. A 3 carbon chain is the longest chain, so I can name it as 2 methyl propane 2 Propane is the 3 carbon chain. On the second carbon, we have methyl, we have OH, both the groups are there. So it is 2 methyl propane 2 So this is how we can complete the reaction with uh, acetone. Okay, we will go to another example. We will convert acetone into 2 methyl butane 2 Here what we are supposed to do is again write the structures first, right? So acetone structure is known to you, CH3COCH3 and 2 methyl butane 2 How many carbons you need? You need 4 carbon chain. On the 4 carbon chain you need methyl and OH on the second carbon, right? So this is the 4 carbon chain, um, 1, 2, 3, 4. On the second carbon, I need a methyl because the name is 2-methyl. Butane 2 So on the second carbon, I am putting OH also, alcoholic group 2 So this is the molecule which we are supposed to prepare from acetone. As you can see, what we need a combination of this CH3, CH3, and C double bond O, right? And this part is now we can see here. This is the part which is coming from acetone. This is the part which is coming from acetone, and the remaining part will definitely come from Grignard reagent. Okay, so let me just clear the writing here. Fine. I hope we can solve it by just taking out this ethyl and converting this ethyl into corresponding Grignard reagent. So this is our Grignard reagent. Carbon is electron rich and this carbon is electron deficient. When you make one, you break one. And you can form the additional product which can be decomposed by addition of water HCl where OMG is now transformed into OH. This is how you can complete the reactions of Grignard reagent. This is a small description. When methyl magnesium bromide reacts with acetone, tertiary butyl alcohol is produced as the final product after hydrolysis. We are going to now the condensation reactions with ammonia derivatives. This is another type of reaction. As I told you, condensation reaction is given by aldehydes and ketones. Derivatives of ammonia. Ammonia is a molecule which is known to us like NH3, and what we are doing is deriving different molecule from this ammonia. So this NH3 is now converted into NH2OH. It is called as hydroxylamine. Then another molecule is hydrazine. So NH2 and again connect NH2, right? And this hydrazine has two NH2s. What you are doing is one of the H is replaced by phenyl group. This is phenyl group, so the name becomes phenyl hydrazine. And after this phenylhydrazine, what you are doing is adding two nitro groups. As per the numbering, it is on the second carbon and fourth carbon. Nitro is present on the second carbon and fourth carbon. So it is 2,4-dinitro phenylhydrazine. Okay. And the last one is semicarbazide, in which we have basically a part from urea. This is the part from urea. Urea is NH2, C double bond O, NH2, and one of the H is removed and we are putting another NH2. So this is the semi-carbazide. So these are the five compounds which are supposed to be reacted with aldehydes and ketones. And when these compounds are reacting, most of the time under mild acidic conditions, they are giving condensation product. Now what is condensation product here? In all these examples, what will happen is that carbonyl of aldehyde or ketone will react with one of the NH2s which is present in these structures, all of them, and water is lost and these two units will be joining. So we'll be always getting a formation of C double bond N. okay, with loss of water. So when a smaller molecule is lost during the joining process of two molecules are joining together with loss of another smaller unit. Such reactions are called as condensation reactions. Okay, and here you just notice that unsaturation character is still there. So C double bond O, that double bond is still there, but right now that double bond O is transformed into double bond N. So let us see some of the examples. These reactions are not very difficult in terms of writing and completing them, and we should be able to solve them with much ease. So let us look at some examples. Here what we are solving is those ammonia derivatives. The first example is with hydroxylamine, action of hydroxylamine on acetaldehyde. So what we are getting is we are getting oximes as the product when we are reacting hydroxylamine. The equation is something like this, that you write acetaldehyde, then you react with hydroxylamine NH2OH. Just remember that nitrogen lone pair is attacking here on the carbonyl, right? So a connection will be generated between nitrogen and carbon, but it is accompanied by loss of water. So you just remember that you can do the condensation like this. You remove water and make the final product, right, as oxime. So generation of C double bond N is there, and this is how the reaction gets completed. The name of the product is acetaldehyde oxide. The side product is water here, and it is the name of the compound acetaldehyde oxide. Action of hydrazine, which is the second derivative of ammonia. We will try to react it with acetaldehydes. We will write the structures acetaldehyde and hydrazine, and the logic remains the same, that condensation is taking place with lots of water. So the product writing is not so difficult basically. So you will be able to write the product, and the name of the product will be hydrazone. Okay, so it is prepared from acetaldehyde. So the product will be called as acetaldehyde hydrazone. Okay, we'll go to now the third derivative of ammonia, that is phenylhydrazine. Phenylhydrazine is nothing but hydrazine with the phenyl group here, right? And again the same logic is working, like water is lost, right? So you will be able to complete the condensation reaction. The product will be called as acetaldehyde phenyl hydrazone. So what we have done so far is, as far as ammonia derivative is concerned, we reacted hydroxylamine NH2OH, we reacted hydrazine NH2NH2, we reacted phenylhydrazine NH2NH, and pH is there on hydrazine. Now we'll go to the another derivative of ammonia, that is 2,4-dinitro. We will look at the fourth derivative of ammonia, 2,4-dinitrophenylhydrazine. The product will be 2,4-dinitrophenylhydrazone. So what we are doing is acetaldehyde is getting reacted with 2,4-dinitrophenylhydrazine. So because of these two nitro groups at the second and fourth position, the name is 2,4-dinitrophenylhydrazine. What you are supposed to do is nothing but the simple condensation reaction, and loss of water is now generating a double bond between carbon and nitrogen, and the product will be called as 2,4-dinitrophenylhydrazone. And the last derivative is the last derivative of ammonia is semicarbazide. It is getting reacted with acetaldehyde. So this is semicarbazide. Here what we are supposed to notice is that the lone pair of nitrogen is involved in resonance with carbonyl, so not free to attack. And this particular nitrogen at the end is NH2, and it can basically attack on this carbonyl, and bond can form between these two structures. With loss of water, you complete the condensation reaction, and what you have got is acetaldehyde semi-carbazone as the product. So the name of the product will be semi-carbazone. Now I have just basically reacted these five derivatives of ammonia with only one molecule, that is acetaldehyde. What you can do is take other examples like propanol or isobutylaldehyde and some ketones as well, and react them with each and every derivative of ammonia. Like propanol, you take and try to write all the five reactions here with these five derivatives. Similarly, you can take another ketone and try all the reactions with these five derivatives. That will give you enough practice for uh, the condensation reaction of ammonia derivatives. Okay, in the second part of the video, we will look into the remaining reactions of aldehydes and ketones. That will be the part 2 of the same video.